Welcome students. The next problem we are going to see in this video, and it is problem number 1.4 in page number 8. Take your book, otherwise you just copy this in your notebook. If you are copying it, it will be better. For problems, you keep a separate notebook. That will be easier for you to recall, and you will be expecting a compulsory problem, and most of the competitive examinations in physics will have the questions only in problems. So try to solve. Okay, come on. Take down the problem, or you just take the book and read along with me. It is given. Calculate the electrostatic force and the gravitational force between proton and electron in a hydrogen atom. So you know you are having an hydrogen atom. At the center you will be having proton, only one proton, and only one electron, no neutron in hydrogen atom. So this is electron, this is proton, and they are separated by a distance. Let us consider it as r, that is 5.3 into 10 to the power of minus 11 meter. The magnitude of the charge of the electron is 1.6 into 10 to the power of minus 19 coulomb. Charge of proton is also same, but electron is negative and the proton is positive. And mass of the electron is 9.1 into 10 to the power of minus 31 kilogram, and mass of the proton is 1.6 into 10 to the power of minus 27 kilogram. Breathe on. See, you are asked to calculate the electrostatic force between the proton and electron, and also you are asked to calculate the gravitational force using universal law of gravitation. Again, you go through the problem and let us write the data that are being given. You just see the problem is calculate the electrostatic force and the gravitational force. What is the electrostatic force? We are asked to calculate Fe, the electrostatic force. Then we are asked to calculate the gravitational force Fg, Fe and Fg. Between proton and electron in the hydrogen atom, they are separated by a distance. So distance of separation are equal to 5.3 into 10 to the power of minus 11 meters. The magnitude of the charges, let us consider charge of electron. I am writing it as Q of E. Magnitude alone I am writing, so it is 1.6 into 10 to the power of minus 19 coulomb. What is the charge of proton? Charge of proton, again its magnitude 1.6 into 10 to the power of minus 19 coulomb. Then mass of the electron, let us write like this, m suffix e. Mass of the electron is 9.1 into 10 to the power of minus 31 kilogram. And let us go for mass of the proton. Mass of the proton is, we can write it is 1.6 into 10 to the power of minus 27 kilogram. And these are the given data. From this data, first of all, let us calculate Fe. So let us go for the solution. In case of the solution, electrostatic force is, we know, constant, that is 1 divided by 4 pi epsilon 0. No medium was represented here, so we have to consider the medium as a free space or air, multiplied it with two charges, charge of electron, charge of proton, divided by square of this distance. Now you substitute the value. What is 1 by 4 pi epsilon 0? It is 9 into 10 to the power of 9, multiplied with, what is charge of electron? It is 1.6 into 10 power minus 19 into 1.6 into 10 to the power of minus 19 whole divided by r square it is 5.3 into 10 power minus 11 the whole square. Try to simplify it using what? Try to simplify it using logarithms. If you want, you can go for one more step. F of e equal, so I can write 9 into, instead of 1.6, I can write it out as 16 into 16 into. So if it is 16, this becomes 10 power minus 20. This becomes 10 power minus 20. So 10 power minus 40 whole divided by. I can write this as, instead of 5.3, if I am writing it as 53, then it is 10 to the power of minus 12. Squaring it out, I can write 53 into 53 multiplied with 10 to the power of, 12 square 1 ratio 10 to the power of minus 24. Simplify and calculate, you will get the answer as f of e equal to 8.2. Okay, you check it out, into 10 to the power of 10 to the power of minus 8 Newton. See, this is the answer given in your book. Since it is an example, I have not worked it out. You just confirm it by taking the logarithms. Now, what is the next one? The next one is f of g. You are asked to calculate gravitational force according to universal law of gravitation. I can write f of g equal to g into mass of electron, mass of proton divided by square of the distance. So substitute, what is g? 6.67 into 10 to the power of minus 11 into mass of electron 9.1 into 10 power minus 31, mass of proton 1.6 into 10 to the power of minus 27 whole divided by 5.3 into 10 to the power of minus 11 the whole square. Simplified, f of g will be then equal to, if you want you can write like this, 6.67 into 9.1 into 1.6 into, on simplifying, 31 plus 10 41 plus 1 42, 42 plus 7 49, 59 69, 10 to the power of minus 69 whole divided by 5.3 into 5.3 multiplied it with 10 to the power of minus 22, and on simplifying you will be getting 3.4 into 10 to the power of minus 47 Newton. Check it out. I have not checked out, you check it out. Okay, now this is the problem over, but you can compare the value of Fe with the Fg. So let us put it here, comparison. What we are going to compare? Comparing between gravitational force and the electrostatic force. You take the ratio, so ratio of f of e divided by f of g. What is f of e? 8.2 into 10 to the power of minus 8. So this value is considered to be what? This value is considered to be very high compared to what? Compared to gravitational value. See, when you are considering about what? When you are considering about the value 8.2 into 10 to the power of minus 8 divided by 3.4 into 10 to the power of minus 47, dividing it, you will be able to get it out as 2.41 into 10 to the power of 39. So you can write on cross, this is Fe divided by Fg. When you are cross multiplying, Fe is equal to nearly, let us leave this, 10 to the power of 39 times f of g. So f of e is very greater than that of f of g. Gravitational force is very larger than that of electrostatic force is very larger than that of gravitational forces. That is the reason why, since the electrostatic force is considered to be high, when you are rubbing a comb or a scale with wool or a fur or a dry flannel, they can able to attract the lighter objects. That is the reason why the lighter objects are attracted towards the rubbed rods with a dry flannel. I think you will be very clear with this, but the problem here is you have to check it out. This problem asked in this year, this current year, they have asked this question for 5 marks. So you can expect this problem again and again. So try to solve using logarithms. Hope you should have understood this. Thank you. Let us meet in the next video with the next concept. Hereafter you have to go with exercise problems, that also will do. Thank you. All the best.